Thank you and good morning, everybody. So I'm Rune Fisker. I'm out of our headquarters in Copenhagen. I started out 17 years ago in a one-room apartment in Treshape in Copenhagen. Today we are 1,100 people. We hired 300 people this year. So it's been quite a journey. It's still very fun every day. And all those people, except 10, are doing digital dentistry, CAD systems and scanners. And this is what I'm going to tell you about today. So why am I here at all? I'm responsible for Trias. I'm responsible for the lab business globally. It's because I think there's a fantastic thing to do in dentures, in digital dentures. It's my work, of course, but it's actually also my hobby. I've used too much time on digital dentures. And why do I do that? Because if I was rational, because I think we can really change something here. We can make a better world, and we can improve patient experience. So I hope one day I might be the denture prince. I don't know, we'll see. Okay, so let's get going. So there's a little bit of an agenda. I will also talk about removables. I will talk a little bit of trays. I will talk a lot about dentures or full dentures, a little bit of intraoral scanning more, and then some next steps on how I see the future. So removables. I actually think we have a little bit too little attention on partial removables. Sorry. I mean, 50% of all what you do is partials, at least in the RS lab. I mean, there's a lot of cases there. And removables, at least the frameworks, are actually fully digital today if you want to do it. And you can gain a lot of time. So I'm just going to show a fast video here on the removable software. So here you see a removable software. It follows the classical workflow. We can block out wax. We can remove wax. We can set up teeth. So that's pretty cool in digital. You can set up teeth before you design the actual framework underneath, papered by teeth or crowns, not dentures or removal of frameworks. We can set up the different patterns here, the retention grid. We can move it around. Notice also that we can scan texture on the model. So the technician here have actually been drawing with hand first. So I want to make revolution, but I believe in evolution to achieve revolution. So, and you can see here, you can just follow the lines. You can see how the guy that designed it followed the lines. We can place occlusal rests. And all the time, of course, we have the waxing tools to do it. We can like minor connectors, like we always do. We can basically replicate what you do today. Try again to see how we block out wax. We block out wax in seconds. We just click and wax is blocked out. We can add clasps. We can change the clasp form. We have clasp shapes you can use. We can go and add the finishing line here. And again, everything is flexible. You can see we can do stipple wax here, I believe. And now you can sculpt. So this is your virtual wax knife if you're not familiar with CAD/CAM. So you virtually wax. You can play attachments. You can play metal dummies. You can place all kind of shapes you want. And finally, you can do wax patterns. You can make runners here. You can make tissue stops. You can basically make all the things you're used to do. And you can do it much, much faster than any digital technician, manual technician could do today in the complete traditional wax workflow. So why are you not all doing this today? That's actually a good reason. And the reason is here. That is because the production is still challenged, I would call it. So guys, if you look at the traditional setup down to the traditional design, etc., until you produce, we are massively faster. This is, of course, a speed-up video, but you can do it in 10, 12 minutes, the whole thing. You can do it. There was one saying yesterday, I will always start with virtual, not with virtual, with conventional. I mean, guys, in the start, you make drawings on the models. But why don't you just draw on the software? We thought the same years ago and fixed. Drawing on the models were good, but no one does that anymore. I mean, you just set the margin line. You don't sit and make your red line anymore. You just set the margin line in the software. And the same you're going to do with removables and later on also your dentures, as you see. But it can be a transition. Evolution is good, even though we want to do revolution. Okay, to produce RPDs frameworks here, you can do casting. You can do laser sintering, so that means metal printing. There's no doubt eventually laser sintering will take over, but today if you want to do this, you unfortunately, you will typically, I would rather say, print your wax and you will cast it. And it's a little bit challenging because you're casting without a refractory model. So you need to be careful what you do. You need to follow procedures, but you can cast and you can save a lot of time. And you might be able to bring back removable frameworks into your lab again instead of outsourcing it to China. There are quite a lot of people in Europe that are actually laser sintering. There's also a 3D RPD here in the US. I don't think they really took off, to be honest, but there are people, quite a lot of people in Europe that are laser sintering. You can, of course, also mill, as we saw yesterday, PMMA, like Justin showed yesterday, or Solvay, as we have in here. And there's also a possibility to do flexible workflows. That was fast about the production, guys. There's a big opportunity to be significantly more efficient on doing frameworks. I will be happy, or we will be happy to show you more about that later. All right, then about triage or intraoral scanning. Sorry about intraoral scanning. Intraoral scanning is literally taking off these years, and we are selling a lot of scanners, and other good colleagues in the business are also selling a lot of scanners. We have done a market survey. The market survey shows in 7 countries, including the US, that 50% of all dentists that don't have a scanner today are considering to buy one. 50% of all dentists. Today in US, the numbers are 10% of all cases on fixed, in general, are going. BJ, you are on 20, how many of your cases were digital today, intraoral scans? 25. So BJ is row dental down here, has 25% of all his cases being digital. If you guys are not ready to receive digital cases on your fixed side, you are going to be under significant pressure. We will talk a little bit more about the removables, where you have a little bit more time, but you guys need to be ready to receive digital scans, and that means you need a digital system in-house, because you cannot convert digital, or you can, but it's not efficient at all and not make it competitive. You cannot convert a digital scan easily back to a conventional method. You can, but it's very inefficient. All right, so what about these scanners? Where are they today? There has been tremendous progress on them. There are a range of different scanners out there. Here you see one scanner from an unknown manufacturer. And you can scan fast. So you can also see it next door here. So you can see how fast you scan. To be honest, our scanners so far have been optimized for scanning teeth. We have spent very, very little time on optimizing for edentulous. We are doing that as we do right now, as we speak right now. So you will see scan times on edentulous which will come close, if not there, then close to what you see here. And one of the cool things about actually scanning the edentulous, this is the soft tissue that's the problem, but when you come to the palate, it's super easy. It's actually easier to scan the palate area than it is to scan the teeth itself. And you will see that in 2 seconds here. So you can see it just moves around. He scans the teeth, and he scans the palate, and you can see how easy it is. And it's not, I mean, it is easy to scan the palate. It's hard to scan the lower, because there is so much, as an edentulous, lower is hard to scan today, because we haven't done our homework, we haven't optimized the software for scanning edentulous, and because you have so much soft tissue down there. What happens now, and all scanners work the same way. You scan the upper, you scan the lower, you scan the bite. Some scanners have 2 bites, others have 1 bite. But you can see this is where we are today with the cutting edge technology, and it is not bleeding anymore. It was bleeding some years ago. Also the 3D scanner was bleeding, even physically, because our tip was hurting people. So, but you can see where we are today. This is a scan, 41 seconds, and it's by far faster, obviously, but also many ways also a better scan, a more accurate scan. So intraoral scanners, guys, are coming, and they are coming big time. I don't think 50%. I dream about 50% buying a scanner in the next 3 years. I don't think that's going to happen. But for sure, a lot of people are buying scanners already this year. I can tell that from personal experience. All right, let's move on. So it's important to understand that intraoral scanners are much more than conventional impression. You can do shades, you can do colors, and you can do stuff like this. So this is what we are going to launch later this year. What we have here is my dream for the last 10 years. It's patient-specific motion acquired with an intraoral scanner. So how does it work? You scan your upper, you scan the lower, then you put the scanner in, and you chew. So the patient is basically chewing. We promise we'll show that live at Greater New York. So if you're coming there, interview. But we can also acquire now motion with intraoral scanning. And that, of course, means that we can make much better prostheses, much better crowns, because we're going to play that motion within the CAD software. So an intraoral scanner is much more, and we are not at the end, not by us and not by our competitors. There are many more ideas coming, especially on the software side. And there's actually some other cool ideas like patient monitoring and so on that we can also use. All right, so is RPDs digital today? Yes, RPDs are fully digital today. I know the first 10, 15 labs and that do RPDs out of scans from an unknown scanner today. And I don't know if you can do it on other scanners, to be honest. But there's thousands of cases. These cases here I got last week. I just called a local lab in Denmark. Can you send me a couple of your Trias cases, because I need some good cases? And this was just what he just popped out from the last week or two. He had just, and it's not a particular big lab. So Trias RPD cases are working today. And it's really good, because you have no pressure on the gingiva. You don't retract teeth. So I actually don't think you can make a better impression than with an intraoral scanner when it comes to RPDs because of the workflow. All right. This particular lab is also laser sintering all their cases. So that means metal printing. So they are metal printing all their cases. They are saving 70% work time compared to the manual workflow that they had a year or two ago. 70%. But these are too expensive, in my opinion. It's $100, so that's not efficient in the US. But for higher salaries in some part of Europe, it is sufficient. But these are all metal printed, and they love them. They work good. They have good properties on the clasps, which have been the problem previously. So laser sintering or metal printing will also come to RPD frameworks at some point. All right, Justin also talked yesterday about the custom tray. I'm just going to highlight it today again, that you can do custom trays. Very efficient, 5 to 7 minutes to scan an impression. No model here. We go model free because we don't have time to make a model. So we scan the impression, or we take an intraoral scan, and you can scan impressions great today. And especially for these things here. They're so easy to scan, there's no teeth, right? And also one thing that's really cool is that if you design them, you can also put, if you know where if you plan your implant position, if you do implant planning, you can place the holes for your transfer pins, if you're still doing it conventionally, in the system, and you can print on different printers that have materials. I'm just going to send a couple of those around here so you guys can see. Of course, this is a cheap product. I mean, does it make sense to print? In Holland, you're printing 500 a day because it makes a lot of sense. I also think it makes sense for you guys, but of course, this is a cheap product, and you don't buy a system to do trays. You also use it for trays. All right, so let's go to dentures. It's clear that you can't do a denture digital today. There's new ways to capture the patient information. We have seen Evident, Pala, Ivoclar has a system, also Baltic Denture has a system. And I mean, you can clearly reduce the number of visits if the dentist wants to do it. Because guys, when I talk to people, there's a little bit mixed feedback on these workflows, to be honest. Some people manage, like the denture queen, the doctor from yesterday, sorry. She can for sure do it because she is top 1%. Can every dentist do it? I don't think so. And anyway, guys, I want to make a revolution. I wake up every morning to change the world. So, and that was not because the guy before said that. Anyone from TreeShape can confirm, I wake up every morning to change the world. And sorry, I actually forgot that we have 3 of our key developers sitting down here for the RPD and denture software. That's basically the creator of the software. So this is the fathers of the software. I'm just a grandfather. Okay. All right. There is no doubt you can do it, but you don't have to do it, guys. You can work on the conventional workflow if you want. You can transition. You can take evolution and not revolution steps. But of course, there are people that are working well today. There are some systems that are better than others. There are some systems that are more revolutionary than others. Going from initial impression to final delivery, I think is very optimistic. But with 3 steps, as some people are doing in different ways, I think is feasible, and it's for sure going to be feasible going forward. Okay, so going forward to actually capturing the data, so to speak. There are, beside the intraoral scanning, which we'll get back to, there are two main ways you can say. There's scanning models today, so no revolution, just evolution. We scan the gypsum models, we scan the rack streams as they are today. We do 3 scans, the upper and lower model, the lower model, the upper and lower model, and the rack streams together. You can also scan impressions, AMD, you can do the 3D biplate from Ivoclar, which is really cool. You can also just take a duplicate impression and scan that. And when it comes into the software, there is no difference. Whether it's a gypsum model scan, whether it's an intraoral scan from a trias or potentially someone else, or whether it's an impression scan, there is no difference in the software when it has been converted. You can also combine, on 3-shape scanners at least, you can combine multiple impressions. I'm not sure you can do that on all scanners, but at least in 3-shape. You can combine single impressions if you want higher accuracy on the impression taking, and align that with a byte impression. You can also just combine models, impressions, and bytes. It's a free world. We try to make it a free world. We don't want to change your workflow necessarily. We're just trying to adapt to your workflow. All right, we can also, at least in 3-shape, support phase bows. So you can take a standard phase bow if you're still doing that, if you didn't forget it from school. In Germany, people do it all the time. So you can take a phase bow scan, you can mount it in your physical articulator if you want that, and you can transfer the position from your virtual articulator, not just the byte, but the full transposition into your virtual articulator if you want to do that. So also a full articulation. All right, at least, again, there are the different options. And I'm not sure how many of the other scanners can do it, but I think most of them can do. But you can basically scan, and at least there's validated workflows from 3-shape. So, but you can scan from Everdent, you can scan to Pala, you can scan to Baltic in most of the scanners, I think. And you can basically send it to them if you want and just do the scanning. We can at least do that. Okay, let's move on. So, we have this design software. We have seen it before. There's a lot of new things. This is where we have a full team engaged. I'm just going to show you an example of the 3-shape software, which is example, as I said, Exocad, Denture, Wings, and other people also have a software. I think we have shown tremendous commitment the last many years in this, where we have had a full team running for 6, 7, 8 years now, dedicated to dentures, and I hope you will see the result of that right now. But this is, of course, just one example of software. So here you actually see a case. You can see, so that's basically a 3D model. You see here, we can turn it off here, and you can actually see there's even an RPD case here on the lower. And basically what you see my scans here, my gypsum model, so to speak, I have my upper, I have my lower, and I have my wax rim, completely classical. I can then press next, and I cheated a little bit like the TV chef here, because so I have pre-modeled the case to make it a little bit more efficient, careful of time. You can see I can place my characteristic points, so I place my canine point, my incisive papilla, etc. I press next. I place the outer boundary of my denture base. Can of course always go and move it around or draw it if I want to do that and change it. And again, if you make a mistake, you can always go back and change it again. The next step here is where we do the insertion direction or survey and block out. So here I can basically set the insertion direction, so I can change this insertion direction with a single click and do the block out. So really fast and easy. I can do wax trimming. So you remember before on the RPD I was blocking out. Because of the denture, I'm not blocking it out here, right? Because then I cannot get it on the gypsum model. Then you know why. Then you don't get sucking effects, of course, under pressure. So yeah, I can go here and add wax if I wanted. Let's say this is an air bubble. I could add wax if I wanted for that. So I go on. All right, now we come to the real exciting place. So the really exciting place, so now we're going to set up the teeth. That will be a proposal. Today you still need to work on the proposal. We will eventually, of course, make this fully automated, but you will still need to work on it. Here, I have also the possibility to work with a range of different libraries. Here. So I have my different libraries here. I can choose, when we get back to that, you can see I have Vita here, I have Kulsa, I have a number of other libraries here. I can select here between the teeth. So here you see I actually have my classical teeth mold here. I can go and select between different of them, completely classical. So we are working with the different manufacturers of getting the teeth molds in here. And again, there's combination tables implemented, etc. We are now done with that one here. So, okay, so let's now try to go and do some modeling here. Just gonna turn off here. So basically you can see now actually it's most impressive if we do this first from the front here. So I have a number of different modeling steps here. I can move my teeth if I want to change the height of my teeth. I can move them up and down. And just grab the whole, so imagine doing this manually, right? I mean, it will take a while. So yeah, I can go here. I can move teeth in groups. So see when I move once here, I also move the other side. I'm always trying to explain to developers, but I mean, those here get it. It's not a computer game, guys. We are making dentures, but many of our developers sometimes get carried away and think it's a computer game. But I know it's not a computer game. Okay, we move on here. Another cool thing I can do, I can go and individually work on them. So I can go here, I can make this longer, and I can do symmetric design again. So I can see I can make completely perfect symmetry. Then the maybe most cool thing. So depending on how you manufacture your teeth, you can now sculpt them or reduce them and change them into software. Of course, if you do a pre-manufactured tooth, you can effectively not change them. You can reduce them in the bottom, but there's no support today from a milling perspective as far as I know. And others are evident, no, they don't do it, sorry. As far as I know, there's no today people that can support really proper, high-quality reduction of teeth in the CAD/CAM world, so it works. Unless if you use pre-manufactured teeth. If you don't use pre-manufactured teeth, it's a different world because then you are completely free. So here we'll end up not using pre-manufactured teeth. You can also see here I have my occlusion, my contacts. You can see now I can go and grab this one if I want. I can move it around, and I completely freely can bring it out of occlusion. I'm just going to keep it in here. I can also have different handles also here. Didn't show you. I can tilt my tooth a little bit if I want. I can turn it. I have all kind of tooth. I can push it here. I can bring it to contact, or in this case, out of contact with the tooth, with the antagonist. So I can do all kind of magical small tricks here, really designing. Thank you. So I was reminded that I should show you something which is really cool here. So I'll just go back and show you that. Thank you. So I'm just going to go back up here. Okay. So let me just get this away. Yeah. So something that is really, really cool here is that what you cannot do is you can take a patient image in. So you can take a patient image into the software. Remember there was a question about that yesterday, where there was a little bit of a vague answer. I was jumping over there, but I didn't want to say anything. So here you can see, let me actually just, so you can see at first I put some points here. So let me delete the lines. So what I can do here, I can click the pupil points, and that is going to adjust my image. So just this image could be taken with an iPhone with a proper high quality camera or with whatever you want to do. I can then click next here. Oh, sorry. I can add vertical lines here if I want. I can see I need to adjust this a little bit. I can add vertical lines here if I want. I can add one more out here on the nose. Here. So I have guidance. So you know classical lines that can guide me for setting up the teeth. I will cut out the mouth. I'll not explain that. I will align. So that's perfect alignment, guys. So what we do is we estimate the virtual camera. So we will, of course, take the picture with the camera. We look from exactly the same position as the physical camera did, which means is what you see is what you get. No other systems are doing that. Okay, let's go on here. So what I can do now is I can model in the face of the patient here. So you can see now, let's zoom in. Okay, I think it looks a little bit better with a little bit longer teeth. I mean, I'm not a technician, but you get the point, right? So you can sit and model into the face of the patient with what you're actually doing, and you will see what you get if you did a proper alignment. So this is something that you will never be able to do in the physical world. And it's really cool. And that you remember Lee Kolb's yesterday's comment in the panel discussion on fixed, every good lab that does a big fixed case for anteriors does this today. You go on Facebook, you see hundreds of pictures of people doing this on fixed every day when you do a big anterior case. All right, let's move on. And again, I could have moved the whole thing up and down. I could have sculpted it. I could have changed library if you want more or less square. I can do everything in the face of the patient here. What is the problem here with this is that the teeth doesn't look good, right? So I'm actually not fully happy. I'm not fully happy with this because the teeth doesn't look good enough. I cannot show this to the patient, right? It's a little bit, it's not well enough rendered. It doesn't look photorealistic. We will get there with that, but that's the flaw of this right now. It's super good for technicians, but it's not really good for patient communication. We will get back to that later. Okay, so now we are on to the next step here. I did a mistake here, sorry. I will go back. So what we're going to do now is we are gonna go and look at what we can do on the occlusal side. You remember before I had some occlusal penetrations where I was penetrating, and you could see that at the color map if you were experienced with the tree-shape software. And so now what I can also do is, so I will going to adjust that in 2 seconds. What I also have is I have a virtual articulator in here. The virtual articulator is a 100% replica of your physical articulator. And if you transfer the position from the physical articulator into the virtual articulator, you will get exactly the same result. So sorry, I pressed on here before I should have done it. I can see. I know you could have done it better than me, Julia, but I think I should show it. I mean, how many VPs and companies that are here can show and live demo and understand their own software? I think actually this says a lot about the company I come from. Okay, let's go back here. Oh no, I pressed it. I pressed far too many times. Okay, guys, there's going to happen a lot of calculations. Yes, I'm just going to go on in the PowerPoint. I'll get back because I want to show you some more later on here, right? Okay, let's move on. So so we are working with the different big manufacturers here on the library. So we are going to build in libraries. We have Kulzer done, but we just need to find approval from Karl-Heinz and friends over there. We can Vita coming. We have Dentsply coming somewhere next year. We have Ivoclar libraries already and a number of other libraries. So you will have your normal denture teeth in there. You can do other cool things virtually. You can do immediate dentures. You can do virtual tooth extraction. You can do bone reduction if you want to simulate that, and design a denture on top here. Okay, if you're not ready to design, and there are many people that still find it, or there are some people, especially if you have been sitting at the bench for the last 35 years, designing might not be the first thing you do tomorrow, right? And there is an opportunity if you want also to work with design services, or there are a lot of labs, a number of labs that also offer design services, but there's a very big design service called Full Contour that are already doing both RPDs and Subi dentures. I think, as you see, Jesse is down there. So if anyone is interested in Full Contour, design services, he is there. All right, so do we need a try-in? Do we generally need a try-in? I think this is an essential question. And I still think that the try-in gives comfort, but one thing that is cool, that is that you don't have to make a traditional wax try-in. There's, I think, very common agreement about you can print a monoblock. Some people then like to put a little bit teeth on so you can move it. But I must say, what I hear from most people, what I talk to, is a monoblock is good enough. People sometimes draw it or do minor adjustment. A monoblock means it's one piece printed or milled at very low cost. So monoblock seems to be both very cost efficient and widely accepted and you can see over here, this is the lady here with a monoblock in her mouth. You can put a little bit pink on if you want to make it more realistic, but it's a really strong simulation. Eventually, I'm 100% sure we'll get rid of the try-in. Even before that, I believe making dentures is going to be so cheap that you're just going to print the final denture. If it doesn't look good enough, you fix it and you print it again. And printers will be so fast you can do that in 5-10 minutes. So that will eventually not be a try-in. you're just going to print another denture if she doesn't like the first one or the patient. Let's move on. Okay, we believe there's a need for a try-in, or people like a try-in. We want to make evolution on our way to revolution, and we have a full try-in workflow where you can design your denture, do all the design as showed, you can scan and align. So basically take your try-in, any markings you have put on, any grinding that have been done, you can scan it again, and you can basically bring it in and overlay it to existing denture and update your denture. So we have a full try-in workflow if you want to make evolution and not revolution. Okay, the picture I showed you before was not good enough. So we had the face, but the picture was not good enough for present to the patient, right? But we believe we have an ambition of TreeShape of making it exciting to go to the dentist. How many of you guys think you have patients that are excited to go to the dentist? I mean, I'm excited, but I'm also a little bit special. But beside me, I don't think there are many patients that are excited. Okay, but what we have here is a very simple, super simple, small app. You take a photo, you plan your design, very fast, it takes a couple of minutes, and we are coming with, for Chicago next year, a rendering, so you can present a good, great looking 2D picture to the patient, and you know, do we want to be after, before, and after? Is this what you want to look? It's of course to create excitement, but it's for sure also to sell the case and increase case acceptance. And of course, for implant cases, this is big bucks, a lot of money, so we're going to bring that out. Discussing with PJ, I was visiting PJ's laboratory before coming here. He's already doing it in Photoshop, but I believe we can make it much faster and much easier with the small app. A few minutes, and I think, yes, the dentist will also be able to do that himself, but I think you should offer this as a service. Okay, moving on. All right, we talked yesterday about communication. We have, what happened to my sound here? I think I dropped it, fell down. All right, 2 seconds. All right, I'm back again. We have already an app for dentist to dentist communication. So we have an app here, you see it here, that can communicate between the dentist and the lab. So the lab can send design previews to you as a dentist. We also have that app able to send to patients. So we want to engage the patient. We want to make it exciting to go to the dentist and engage the patients. So we can also already today upload TRIA scans to the patient. And so he can show it, upload it to Facebook, show it to all his friends. I also tried to show my scan in the bar Friday evening. It doesn't work. Maybe on dental school, but it doesn't work the bars I'm going, unfortunately. All right, so what you can do here is you have the app. You can basically load the 3D scan, so here's a case. And in 2 seconds, I'll send it around here. You can basically sit here and look at the scan and the design case. Here we go, send it around. Don't call my boss, okay? Another cool thing is about the future is there will also be face scans. So face scan is going to come. Let's see if the iPhone 10 can do it. It has a built-in small low-res 3D scanner, so it has the potential to do it. We also have a CBCT scanner here that can do face scans. The problem with face scans today is typically that the teeth are not scanned good enough, so we need to merge them with a high-quality intraoral scan. But of course, this is the dream for all of us, or at least me, to take the face scan in, do the full 3D, even move cheeks and everything when you do it. We're going to send it around. You can have a look at it. Quality is getting really good. Let's hope that the iPhone X will do the job. Okay, now to the real problem, and this is often my problem. It's a big problem. I make super cool computer game software that design fantastic something, and now we cannot produce it. And that has actually been why we have been hanging around for a while on this denture stuff here. Okay, so there are many different opportunities. So I'm going to go over the 4 main ones. There are also some proprietary ones with Baltic. You saw that earlier today, also very interesting. Avident, as I understand, also have a special one. But we're going to go over those 4 here. So what's the first one here? This is basically what Pala is doing today. Glidewell is also doing it, and a number of other labs. You print a monoblock with the teeth. You do your silicone form. You put in the teeth. Avident Pala has this super cool jig. You can grind down the teeth to reduce them, and then you inject them as you have always been doing. I will call this a good workflow. It works today. It's kind of semi-digital, in my opinion. It doesn't go all the way, but it works. It's a good workflow. It works. You get some setup time gainings, and you can, of course, adapt digital. Another option, which is also working today, is that you have designed your teeth. you mill your denture base, you use pre-manufactured teeth, and you glue in the teeth, as you see over here. We have seen that. A number of people are looking at that. You can see here there's something a little bit special. That's an Ivoclar patented version, where we actually have a glue guide, which is sitting on top of the teeth. You see it up here designed to keep the teeth in the position. So do I like denture teeth from a digital point of view? My feelings are mixed. And why are my feelings mixed about denture teeth? I mean, they are highly aesthetic. They are working today. They are cheap, or less expensive at least. So that's good. They are cumbersome to glue in. The main problem with denture teeth today is that they are not produced very accurately. So because they are molded, molds are old, different molds have different sizes, so denture teeth varies in size. And when you have a very precise CAD/CAM milled pocket, it's hard to glue them in. It's very hard to maintain contacts because they're hard to glue in, so it's hard to maintain contacts, hard to maintain occlusion. You can't do the guide. It's problematic to reduce the teeth, right? You can reduce them from the bottom, like on a gearback, or we also do. But reducing them onto a occlusal surface is not easy. It can be done technically, it's not easy. If you want to do pre-manufactured teeth, we have the solution for you. You can go ahead doing it. You will face some challenges. I also think the teeth manufacturers, and we'll be happy to help them because we have no preference for our method, but we'll be happy to help them to improve this workflow. But today it is a little bit tricky, in my opinion, because of these things. Okay, let's move on. Another option here, which is actually really a very high aesthetic option, is you take a multi-layer PMMA block, you mill out the teeth, you cut back the gingiva. The gingiva is already cut back, and you put on either with triad or classical acrylic, you put on a beautiful denture. Here, gingiva. CMC is doing it, so BJ was doing it the other day. Lee Kolb was doing it. As you can see here, you can create beautiful dentures. I mean, this is a high aesthetic denture. I mean, I'm not a denture guy, but I think I can see if it's pretty or not. So I think this is a high aesthetic denture. Of course, it's still not red in the bottom, but this is a high. You can do truly beautiful dentures with this by taking multi-layer PMMA. You will have proper translucency through the teeth because you have, lighter in the top and darker in the bottom. So this is a really interesting solution. The only thing which I think could be improved is that it's still a manual process to put on the gingiva, which is taking time, right? Okay, another option is actually to mill the base, as we had before, and then mill teeth in one arch. You saw also Lee doing that the other day. So our software can now just mill all the teeth in one arch, and you pop them in. We have what we call a Lego base, Lego connection here in the bottom. So we have basically a special design. We don't have the teeth connection anymore. We make a Lego connection. We're from Denmark, so we like Lego. This is where Lego comes from. So we like Lego. So we might make a small different connection. You have the two parts, and you plug them together, and you are done. Ivoclar have further improved and patented this workflow here. So you mill them slightly oversized. You then glue them in, as you saw Lee doing the other day. Glue flows all over the place. And you mill it one more time, fine milling, and all glue is gone, and you polish the denture. This is a really cool workflow. But that requires that you go with Ivoclar for that. Ivoclar's initial study shows there's more than 50% reduction on labor time. Well, a significant labor time reduction here. All right, then the last part I'm going to talk about is 3D printing. So you can already today print, and I actually have samples here, sorry for that. So here I have the Ivoclar sample here. So here are Ivoclar samples. I'll send them around. Over here. Over here. So 3D printing. So there's no doubt that 3D printing will replace. And we will 3D print all dentures at some point in the future. Are they looking good? They are looking pretty good. Are they looking good enough? Are they strong enough? Yes, maybe. Maybe, I would say. Maybe they are strong enough. Are they looking good enough? You judge yourself. But they are looking very promising. Okay? Here we go. Okay, so a little inspired of the Dr. Cooper. I prefer the denture queen because I want to be a denture prince. Okay, so I was this morning throwing a little bit around with my printed dentures up in my room. I didn't have, any hammers or anything. So I was giving in a little bit. So eventually, I managed to break it. Because I was like, doing hard like this, don't do that on my denture, because it's my last printed denture right now. So you can break it. It is possible to break at least these ones here by pressing hard. I know I'm a strong guy, but I didn't press that hard, I have to say. So is it strong enough? I don't know. Will it be strong enough? For sure. I'm not in doubt. This is already now, a year ago, it was not very good. It's much better this year, and I'm sure it'll be much, much better next year when the next generation of denture material comes. So you can have a look here if you want on this. What are you doing? You're basically printing the teeth, you are printing the base, and you're curing and polishing. All right, I don't have really time to talk about this, but right now we are down here. You can do all the things we talked about, models, surgical guides, splints, trays, and so on. Dentures is on the edge. You will also be able to print crowns eventually. All right, we have a lot of different printers here. There are FDA-cleared materials. The materials are sent around is FDA-cleared. This is developed by Nextdent. The materials is the problem. It's not the 3D printer that's the problem. It's to make the right material and not at least to get it cleared with the right properties. All right, so here's an overview of the manufacturing methods. Monoblocks are super low material cost, not fully digital. Pre-manufactured teeth, high static solution. We talked about it's a little bit cumbersome. Milled, at least Ivoclar, using low neighbor leads. You can modify teeth for single arch and RPDs. It's very aesthetic, at least for one part. 3D printing, super cost efficient guide. You can modify teeth. There are no stock teeth at all, so you don't have to stock teeth anymore. Isn't it a dream? Over here, milling time and overall cost, is that good enough here? Time will show. Our material is good enough here? Maybe, but it will for sure be. All right, and again, buy a system that can do everything. Buy the true open system where you have all the opportunities, because it's not completely clear today which method that will win, even though there are some better methods. All right, intraoral scans for dentures. I have talked to, besides the 2 presenters yesterday, I have talked to 3 guys in the last 2 weeks that are doing dentures based on intraoral scans. You see a case here from an Italian partner we have, who has been scanning, who have done 100 cases intraorally. So you see the design, how it does. Again, there's no difference when you get in here whether it's an intraoral scan or it's a gypsum model. So he's milling. So he's gluing in teeth, which is also great. This is, again, it's a working workflow. He does base reduction. It's milled on the Roland here with Hyperdent. So assembly is a little bit, I don't know if it's better to assemble than Lee is, but assembly is easier. But if you notice very carefully here, you see there are contact issues here. I cannot see it here, but you have open contacts. Try to look there. Did you see the open contacts right there? So it's hard to maintain the contact on this, but it's working and it's cool. Okay, so why do we do digital dentures at all? I think we have a better product. Occlusion fit, stronger. I believe it will be stronger. They are much easier to make. I mean, I can do, I would claim, single dentures a little bit hard, but 2-sided dentures are really easy to do. And you can learn me, give me half a day in your lab, and I can make a denture there. Reduce chair time and number of visits. There is increased profitability. So I think we have a unique opportunity here to make this more efficient and increase profitability for both dentists and for labs. I think it's fun. Hope you think it's fun too. And maybe most importantly, we improve life quality for patients. 3 slides more on looking inside the full digital removable future. There is no doubt we will have new scanners. We'll have intraoral scanners. We'll scan impressions. One of my missions in life is to get rid of the impression. It will take a while. So it takes many years. But I'm very ambitious and optimistic about getting rid of the gypsum model. I'm going to scan impressions and get rid of the impression model or have intraoral scans. And there are better ways to capture patient information. We will print models if we need them, but most restorations and dentures will go model-free. We will have complete CAD/CAM software packages, so I promise you everything you see in your lab today, we can do in the CAD software. We can do everything. The real challenge is to manufacturing it. And here, 3D printing, I believe, is going to replace everything we have in the lab today, especially on the denture side, because there is nowhere where it is as efficient to print as it is on dentures. All right, planning services. Yes, since especially labs should plan more. They should do smile design. They should do implant planning. We also have a lot of software for designing implant dentures. implant bars, etc., but I could not talk about that today within this scope here. So guys, let's change dentistry together, okay? Can you please do me a favor and actually give the hand to the team, development team here also, because they actually done the job.